So this is a simplified sketch of our first prototype. The bottom side absorbs the heat while the top side stays exposed to colder air. In between, we place an TEC model which converts this temperature difference into electrical output. And this was our starting point.
So this is a thermoelectric model. So when there's a huge temperature difference between two sides, it's going to generate the electric voltage through the feedback effects. This is aluminum heat sink. So it's going to attach to one side of the thermoelectric model, and its role is going to spread out the heat efficiently and going to maintain the temperature to stable.
So here is an insulation foam. It is used to isolate half of our structure from its surrounding to retain more heat. Also, here's a thermal paste used on the other side of the TEC for it to transfer heat faster to maintain a more stable temperature difference.
To ensure that electricity and voltage flows through each of our components in our design, we're using a multimeter set on the voltage mode to ensure that electricity flows. And also we use these alligator clips over here to not only help with multimeter measurements, but also to link all our TEC components together.
This is our aluminum plate which serves as cooling surface, helps release the heat to the surrounding air. And here we have some rod which connects the components and provides structural reinforcement.
With the material prepared, we moved into the main building and testing phase.
After some careful testing, we realized that our original design just simply doesn't retain enough heat. So now the question is, how can we retain more heat? After some careful discussion, we came up with a solution that we can simply construct a heat box using styrofoam around the design and leave a hole big enough for the aluminum plate to peek through, thereby maximizing the temperature difference on both sides of the TEC.
Starting from this 3D model, I use it to guide the construction of our second prototype.
Oh no.
Since the day-night temperature difference here doesn't match desert climate, and our product works the best in the desert climate, we will simulate a desert environment for testing.
To simulate desert conditions, we create an artificial temperature gradient. We use a hair dryer to provide continuous heat on one side while placing ice on the opposite side to maintain the cooling. With this setup, we were able to achieve a stable output of approximately 0.5 volts.
Throughout this project, we focus on keeping our design as simple and low cost as possible. While our final prototype is not yet fully optimized, the core idea has been validated. Through iterative testing and simulation, we achieved a stable output of around 0.5 volts, demonstrating that our concept works. This project is not an endpoint, but a proof of principle and a foundation for further improvement.